Here's a puzzle for you. If you drop a stone in water, it sinks. If you drop a coin, it sinks. But when you put an ice cube in your glass of water, plop, it floats. How does some sinks and some doesn't sink in water? Imagine you're sipping a cold lemonade on a hot day. You drop a few ice cubes in, and they happily bob at the top, like lazy swimmers at a pool party. But wait, why don't they sink to the bottom, like a toy you've dropped into water? Why does solid ice float while most other solids sink? Is ice lighter than water somehow? What would happen if ice didn't float at all? Here's the secret. When water freezes, its molecules arrange themselves in a special open structure, like a crystal lattice. This makes ice take up more space than liquid water. Same mass, more space. That means lower density, and anything less dense floats. That's why ice cubes float in your drink and giant icebergs float in the ocean. If ice sank, lakes and oceans would freeze from the bottom up, trapping life underwater. Thankfully, floating ice forms a blanket on top, keeping life safe below. About 10% of an iceberg sticks up above the surface, while 90% hides underwater, like a giant secret. Ice expands as it freezes, which is why bottles of water sometimes crack in the freezer. Penguins and polar bears rely on floating ice for survival. And here's a funny thought. If ice sank, your lemonade would be a boring warm drink because the ice would hide at the bottom where it's no use at all. In space, scientists have discovered exotic forms of ice that doesn't float at all. These weird ices may exist on distant moons. So while Earth's ice floats to protect life, other planet oceans might look very different. So here's your challenge. Next time you have a cold drink with ice cubes, watch them carefully. Notice how they float, melt, and disappear, cooling your drink. Then imagine, what would happen if they sank instead? Take a minute to sketch or write your answer. You'll see why floating ice is one of nature's clever life-saving tricks.